Hello everyone, our today's module is preservation of food by physical method by using radiations. The main objective of this module is to enhance understanding of types, process and applications of various radiation in preserving different types of food. So in this lecture we will discuss why food preservation is needed and what types of radiations can be used in the food preservation, the different types of radiation energy and their possible interactions with food, working of food irradiators which are used in large scale preservation of food, benefits, drawbacks of food processing by radiations. Additionally, I will explain the safety, legal and regulatory aspects of irradiated food. Approximately 25% of all food products are lost after harvesting due to spoilage and attack of vermin and insect. Most commonly, roots and tubers are affected by these agents. In developing countries including India, where handling, transportation and storage conditions are less adequate than developed countries, that is why losses are considerably greater. Moreover, foodborne illnesses caused by pathogenic microorganisms result in thousands of deaths each year. Although there are several physical, chemical and biological methods are available to preserve different types of food, exposing food with certain radiations has potential to considerably reduce both food storage losses and foodborne illnesses. Food irradiation also offers several food applications including slows or delay spoilage due to the growth of pathogens, inhibition of sprout, delay in fruit ripening, increase of juice yield and improvement of rehydration. During food irradiation, radiations target organisms' DNA beyond its ability to repair and organisms can no longer able to continue the process of cell division and the target organism ceases all processes related to metabolic and reproduction. Similar to freezing or canning of food, before exposing food products to ionizing radiations, steps like selection of food, cleaning of food, packing and heat treatment or blanching must be carried out. Radiation may be defined as the emission and propagation of energy through space or material medium. Electromagnetic type of radiation is of primary interest in preserving food. The electromagnetic spectrum may be divided into two categories, one on each side of visible light from radio waves to infrared, where low frequency, long wavelength and low quantum energy radiations related to thermal agitation of the food. Another side of visible light from ultraviolet to gamma ray, high frequency, shorter wavelength and high quantum energy radiations. Such type of radiations excite and degrade the organic compounds and microbial cells without heating of the food products. Food technologists classified radiation of interest in preserving food based on their wavelength, the shorter wavelength radiation being the most injuring to microorganisms. Three types of radiations: one ionizing radiation, second ultraviolet rays and third microwaves. Examples of ionizing radiations are alpha radiation, beta radiation and gamma radiations. Alpha radiations has poor penetration power and has no importance. Beta radiations can penetrate up to 4 to 5 cm and used in surface treatment, whereas gamma radiations plays significant role in preserving food as they have excellent penetration power as well as cheapest form of radiation. They can penetrate up to 30 to 40 centimeters and that is why mostly used in the packaged food treatment. Ionizing radiation is applied to food to improve their keeping quality. Food processed with ionizing radiations are known as irradiated. They are not radioactive and such radiation destroy microorganisms without appreciably raising temperature, hence the process is termed cold sterilization. The unit of absorbed dose is the gray, where 1 gray is equivalent to 1 joule per kilogram. The low doses, that is up to 1 kg, inhibit sprouting in tuber, bulb and root vegetables, inhibit the growth of mushrooms and delay ripening process in fruits. Medium doses, that is 1 to 10 kg, extend the shelf life, eliminate spoilage and pathogenic microorganisms, and high doses ranges from 10 to 50 kg can be used for industrial sterilization and decontamination of certain additives or ingredients. In general, parasites and insect pests which have large amount of DNA are rapidly killed by an extremely low dose of irradiation. Bacteria cells requires more irradiation because they have less DNA, and since viruses are smallest pathogens that have nucleic acid, and they are in general resistant to irradiation at doses approved for food.
The microbial cells are affected directly and indirectly by ionizing radiations. Direct effect, because these radiations are interacting with key molecules, for example chromosomes, where OH radicals cause single or double strand breaks in DNA molecule, resulted in removal of hydrogen from deoxyribose sugar within the cell. Indirect effect, generation of free radicals by radiolysis of water, and later on free radicals can combine with oxygen molecules to produce powerful oxidizing agents that can damage cell constituent. That is why food without water and oxygen require higher doses, usually 2 to 3 times, to obtain the same lethality of food with sufficient water and oxygen. Here in this slide you can see certain process like radaprotization, which is equal to radiation sterilization or commercial sterility that destroy all forms of microorganism, and this process is suitable to only few food products like bacon, because as the high doses of radiation, which is up to 50 kg, may cause color changes and or production of odors. Residuation, it is equivalent to pasteurization of milk, where reduction of the number of viable specific non-spore forming bacterial pathogens achieved. Irradiation levels of 5 kg or below are effective in destroying non-spore forming and non-viral pathogens. This process may be used to preserve the food such as fresh poultry, red fish, spices and condiments. Redurization. In this process, low level of radiation applied to improve the keeping quality of a food by causing substantial reduction in the numbers of viable spoilage causing microorganisms, especially gram-negative non-spore forming rods. Dose of radiation below 2.5 kg is sufficient to increase the shelf life from 2 to 6 fold of fresh meats, poultry, seafood, fruits, cereal grains and vegetables. In this slide you can see radiation level, dose of radiation with examples. Low doses, that is less than 1 kg, is used for sprouting inhibition, disinfestation of insect, parasite disinfection and delay of ripening. For sprouting inhibition, dose level is 0.06 to 0.20 kg. For example, potatoes, onions, garlic, ginger root and chestnut. Disinfestation of insect, dose level 0.15 to 1 kg. Cereals, legumes, fresh including quarantine treatment, dried fruits, dried fish and meats. Parasite disinfection, dose level 0.3 to 1 kg, and delay of ripening, dose level 0.5 to 1 kg. Medium dose, that is 1 to 2 kg, that is used for extension of shelf life. The dose level is required 1.0 to 3.0 kg for raw fish and seafoods, fruits and vegetables. For removal and inactivation of spoilage microorganism, dose level is required 1.0 to 7.0 kg. Raw and frozen seafoods, pathogenic bacteria, meat and poultry, spices and dry vegetables. Improving technical parameters, dose level 3.0 to 7.0 kg. Increasing juice yield properties of food, grapes. High doses, that is more than 10 kg. Industrial sterilization, dose level 30 to 50 kg for meat, poultry, seafood, sauces, prepared meals, hospital diets, decontamination, virus inactivation, enzyme inactivation, food additives and ingredient dose level 10 to 50 kg, spices, enzyme preparation and natural gum gel, etc. Low doses up to 1 kg inhibit sprouting in tuber, bulb and root vegetables and delay physiological process. Medium doses 1 to 10 kg extend the shelf life, eliminate spoilage and pathogenic microorganisms. High doses 10 to 50 kg for industrial sterilization and decontamination of certain additives or ingredients.
It is a non-ionizing type of radiation and considered a powerful bactericidal agent, with the most effective wavelength being about 260 nanometer. Microbial proteins and nucleic acid showed maximum absorbance. In general, UV light is absorbed by purine and pyrimidine base leads to the formation of covalent bonds between adjacent thymine molecules, resulted the formation of thymine dimers. These may interfere the process of DNA replication as well as disrupt normal gene functioning, which results in creating new mutants. Microwave radiations act indirectly on microorganisms through the generation of heat in the microwave oven. When electrically neutral foods are placed in an electromagnetic field and the charged asymmetric molecules are driven first one way and then another, in this process each asymmetric molecule attempts to align itself with the speedily changing alternating current field, and the molecules oscillate about their axis while attempting to go to the proper positive and negative poles. Intermolecular friction is developed with apparent heating effect. This temperature effect is accountable for killing microorganisms in food. Microwave radiations are used both commercially and domestically in domestic microwave ovens or in catering to defrost frozen meats before cutting, in blanching of vegetables and fruits, destruction of molds in bread, pasteurization of beer and sterilization of wines, etc.
Before application of radiation on food and products, several factors should be considered, such as type of organism, number of organism, age of organisms, composition of food, oxygen concentration and the physical state of food. During the process, the packaged food is exposed to a carefully measured amount of intense ionizing radiation in a special processing room that is called irradiation chamber for a definite period of time. In food irradiation, three types of ionizing radiation sources are employed. Cobalt-60 for gamma rays, that is most commonly used due to deeper penetration, electron beam generator and X-ray accelerators. At commercial level, an industrial irradiator is used for exposing food products to ionizing radiation, placed in a room with concrete walls of 2 meters thick that contain the radiation source such as cobalt-60. A conveyor automatically moves the packaged food into processing room for irradiation. Here, food products do not come in direct contact with radioactive materials. Before entering of workers into the processing room, source is lowered to the bottom of a pool where water bath absorbs the radiation energy and provide protection to the staff or workers engaged in the food irradiation facility. Food irradiation has multiple applications, such as it ensures that microbes or insects are not transported across border, which fulfills quarantine needs for international trade with fresh fruits and vegetables. It significantly reduces the number or kills bacteria, insect, parasite that can cause foodborne illnesses. It extends the shelf life of food by eliminating or killing spoilage causing microorganisms and by slowing the ripening process and inhibiting the sprouting of root vegetables like onions and potato. It is useful in maintenance of safety standards in food production process, and it is also applied to food products after their final packaging done. Though food irradiation is beneficial up to a certain extent in food preservation and can replace chemical hazards to health, but several adverse effects are also noted, which we will discuss one by one. Food loses its nutritive values because of destruction of vitamins and nutrients contained in food, and few protein food are flavor sensitive to irradiation and may develop off flavor. For example, it affects some important constituent of food. For example, vitamin E level can be reduced by 25% after irradiation and vitamin C by 5 to 10%. Sometimes softening and discoloration may occur in some fruits, and milk may acquire an unpleasant taste. Blocking of the degradation process of microbial and enzymatic during irradiation process makes food fresher than it actually is, and food like fresh food, but actually it is not fresh and may have lost much of its nutritional component. Such type of changes mislead the consumer because it is become tough to differentiate the natural fruit to treated fruit. It is believed that food irradiation leads to production of free radicals and highly reactive products which react by forming product of radiolysis uncertain and sometimes causing deterioration of organoleptic qualities of food. There is a possibility of adverse reaction of radiolysis product on human health which cannot be ignored, though these type of effects are not yet reported. Irradiation processing of food is its low level of acceptance by consumer because of perceived association with radioactivity. Radiations are ineffective against viruses as they are the smallest pathogens that have DNA or RNA, and they are relatively resistant to irradiation at the levels approved for food. Prions have no DNA or RNA, therefore also not affected by irradiation at levels approved for food. In the process of food irradiation, we uses of nuclear technology which is greatly concerned with our environment, and hence it raises all environmental safety issues relating to application of such type of technologies.
Food irradiation technology has been the matter of intense research for more than 50 years. Based on all the scientific informations available, there is no health risk associated with irradiated foods. As such, food are not radioactive, although no food is 100% safe, but till date no scientific research has shown irradiated food causes cancer even if exposed 10 times of the approved radiation level.
Legal and regulatory aspects of food irradiation. Trade in food and agricultural products have become increasingly global since the establishment of the World Trade Organization (WTO) in 1995. Before this, importing countries were essentially free to frame their own rules. Currently, all governments that belong to the WTO will have to follow one set of rules and standard procedures. Besides, especially relevant rules and rule-making bodies like the Codex Alimentarius Commission for irradiating food under WTO agreements. Under this agreement, member states are free to adopt and modify standards into their national regulation. That is why regulations related to food irradiation varies from country to country.
According to the Codex standard for labeling of pre-packaged food, it is mandatory to inform consumers about irradiated food and requires the label Radura, which is an international symbol of radiation, on any food that has been treated by ionizing radiation or containing irradiated ingredients, and also bear a statement indicating that the food was treated with or by radiations. In 2003, the Codex Alimentarius Commission withdrawn any upper dose limit for food irradiation along with clearance and declaration that all food are safe to irradiate. Although some countries adopted the codex without any restriction, whereas few countries permitted the radiations for fresh fruits for fruit fly quarantine purposes. Food irradiation is a promising new food safety technology that can reduce or eliminate foodborne microorganisms, insects, and parasites. This food technology has been studied for more than 50 years and is increasingly accepted by regulatory authorities all over the world, since it delivers an additional layer of safety to several food products like meat, seafood, and poultry that are more susceptible to pathogenic microorganisms. Nowadays, the worldwide interest in food irradiation technology increasing as it may provide cheaper and more effective option for food manufacturers to ensure the safety of their products.